Stella and her friends are playing a game of tug-of-war. Neither side seems to be winning, though. Sam has come and joined the opposing team. There, Sam's team has won. How do you think Sam helped his team win? Sam upset the balance of forces between the two teams and tipped it in favor of his team. What do we mean by balanced and unbalanced forces? Let's find out. Stella and her friends are playing a game of tug-of-war. Neither side seems to be winning, though. Sam has come and joined the opposing team. There, Sam's team has won. How do you think Sam helped his team win? Sam upset the balance of forces between the two teams and tipped it in favor of his team. What do we mean by balanced and unbalanced forces? Let's find out. As you know, a force is a push or a pull. Forces may occur in pairs and can be either balanced or unbalanced. Balanced forces do not cause a change in motion. They are equal in size and opposite in direction. In the tug-of-war, when there were equal numbers of participants on both sides, the forces applied on both sides were equal and opposite in direction. As a result, the forces were balanced, and the rope stayed pretty much in the same place. Try arm wrestling with a friend who is about as strong as you. What do you think the result will be? Well, at least in the beginning, you will both be pushing as hard as you can, but your arms won't budge. This is an example of balanced push forces. As the push forces exerted on both sides are equal, the resultant force is zero, and there is no change in motion. So what causes a change in motion? Let's consider the tug-of-war again. When a person was added to a team in the tug-of-war, the balance of forces was disturbed. The rope moved towards the team with more people. Unbalanced forces cause a motion or a change in motion. In other words, if a force results in motion or a change in motion despite an opposing force, you have an unbalanced force. That's because the forces in this pair are not equal and opposite. Consider a scenario where your family car has broken down and you need to push it to the edge of the road or into a car park. The road is rough. Initially, when you start pushing, the car doesn't move at all. Why doesn't the car move? What force is acting on the car to balance the force you're applying? The car doesn't move initially because of the force acting between the surfaces of the wheels and the road. The force that acts between two surfaces in contact is called the frictional force. Thus, frictional force balances out the force you apply to the car. When your friend joins you and both of you push harder, the car starts to move. This happens because the pushing force is bigger than the frictional force. Therefore, the forces are not balanced anymore. To summarize, if the net or total force acting on an object is non-zero or more than zero, the forces are unbalanced. How would you calculate the net force where forces are unbalanced? When unbalanced forces act in opposite directions, their combined force or net force is equal to the difference between them. For example, suppose Sam applied a force of F2 units to the rope. Therefore, the total force exerted by his team would increase to F1 plus F2 units. Net force on the rope would become F1 plus F2 minus F1 units. Thus, if two forces are acting in opposite directions, net force is calculated by subtraction. The net force will act in the direction of the larger force. Forces acting in the same direction combine by addition. Consider the example in which you and your friend pushed the car into the car park. Suppose you and your friend were each applying a force of 1.5 units in pushing the car. And the frictional force between the wheels and the surface of the road was 2 units. Then, net force equals larger force minus smaller force. Net force equals 1.5 plus 1.5 units minus 2 units. Net force equals 1 unit. The value of the net force is greater than 0. Hence, the forces are unbalanced. How do balanced and unbalanced forces impact a body? When the forces applied on a body balance each other, either the body will rest, or, if it is already moving, it will move with uniform velocity. How does a helicopter remain hovering in the air? The force of gravity pulls it down, but the downward push of the rotating blades on the air balances the weight of the helicopter, keeping it steady in one place. When forces are unbalanced, the extra force causes the object to move if it was at rest. If the object is already moving, the extra force causes the object to speed up or accelerate, or slow down, and or change its direction. There was no external force acting on the bike when the rider stopped pedaling. So why didn't the bike stop? Here is another activity for you to observe. If you pull out the cardboard with a jerk, the coin will drop into the tumbler. Why doesn't the coin get pulled away with the cardboard? Both the phenomena that you just observed can be explained through the law of inertia, also called Newton's first law of motion. Newton presented three laws that govern the nature of motion. These laws are derived from Galileo's ideas and experiments. Let's take a look at Galileo's experiments with inclined planes. Consider a marble resting on a plane inclined on both sides. Now, the marble is released from the left, that is, end A. The marble rolls down the slope and travels up the other slope till it reaches the same height from which it was released. In this case, the inclinations of the planes on both sides were equal. Therefore, the distance covered by the marble rolling down was the same as the distance it climbed up on the other plane. Let's see what happens if the angle of inclination of the right-hand side of the plane is gradually decreased. The marble travels a longer distance till it reaches its original height. The angle of inclination of the right-hand side of the plane has been reduced to 0. The plane is horizontal. How far will the marble travel now? It travels quite a distance. The marble stops eventually because of the frictional force opposing its motion. In practical situations, it is difficult to achieve zero unbalanced force because of frictional force. However, friction can be minimized by using a smooth marble on a smooth surface and using lubricants. If the surface of the plane was completely frictionless, the marble would travel forever, trying to reach its original height. Thus, a marble in motion would keep moving if unbalanced forces or the net force on the marble was 0. From this, Galileo deduced that an unbalanced external force is required to change the motion of an object. But once the object starts moving, the application of no net force is required to keep it in uniform motion. Consider the example of spacecraft Pioneer 1, launched about 20 years ago. Deep in space, it keeps moving even without the aid of engines, because there is no frictional force in space to stop it. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. Newton's first law of motion states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. That's why the first law of motion is also known as the law of inertia. Can you think of some real-life applications of this law? Well, consider the concept of wearing safety belts in cars. Why do we need these belts? When a car is moving, we are at rest with respect to the seat, but moving along with the car with respect to the road. In the unfortunate event of a car crash,